Um, what we're going to present today is something that we presented internally to what we refer to as the Rack Pack organization. These are engineers that are in the Exadata development organization that actually act as facilitators to help customers deploy their Exadatas with a specific focus on clusterware, ASM, grid infrastructure. What we're discussing, or at least what we presented to them, what I'm going to present today, is essentially what we have observed in the field in terms of what strategic customers are doing with multi-tenant. And today I have with me Chan Tuzla. In the product management group for multi-tenant, there's Patrick Wheeler, and then I'm John McHugh, and I have Chan Tuzla with me today. So let me just get this thing working. So we're just really going to focus on three things. One is the database for PDBs, database resource management and lockdown profiles, which were introduced in 12.2. And what we're going to focus on is essentially just recap what they are and show you how we actually implement both the resource management and lockdown profiles in our own fully managed database services in OCI. And then the other piece of this is we see customers struggling with database as a service implementations for their private clouds. So just discuss what our approach, again, in our own fully managed services and autonomous services in OCI. So with that, let's just kind of kick it off. Just a quick recap for multi-tenant. Multi-tenant's been out there for about 5 years now. So if you're not familiar with this slide, either from your account teams or from product management, you should be. Essentially what multi-tenant is a container database, providing, which is represented as the gray piece down here, which presents database infrastructure to hosted tenants. And those hosted tenants are self-contained pluggable databases where applications run unchanged, and each pluggable database or tenant has its own data dictionary and associated data files. And because of this level of isolation, we can unplug, plug, and move things around either online or statically through an unplug plug operation. Because they're all plugged into a common container database, we can run across all containers, if given adequate privilege, run across all containers to query, look at, generate reports, or even manage as a coarse-grained structure, backing up the entire container database and all tenants. Or we could subdelegate and give privilege down to the individual tenant if we were to allow them to back up their own tenant or restore their own tenant. Again, providing coarse-grained, fine-grained management capabilities as common operations. And because the container database is providing database infrastructure, we get far greater efficiencies in terms of how we use the shared memory and CPU. What we see consistently across the board in the field as we talk to different customers that are trying to implement multi-tenant or have implemented multi-tenant is basically to rationalize their current environments by obsoleting servers or processes or software to consolidate in their data centers. And part of that exercise is to implement and impose standardization in the environment. And each of these lend themselves very well to defining an automation in the environment so that you're building out specific templates and you minimize the risk by automating risk in terms of just screwing things up across different platforms, but minimizing risk and essentially creating a frictionless deployment model for database as a service. Obviously, the objectives are to reduce cost. So this is a slide that we've gotten from one of our customers, FinServ in New York. Basically outlines the problems we we're trying to solve. So there are multiple options for provision Oracle database, and many customers have scripted their own deployment models, but oftentimes independent lines of business under the same company have their own scripting mechanisms to create their own databases. There's no tool, particularly for PDBs, to manage the framework as a single entity. So the manage many as one certainly lends itself well when deploying multi-tenant. And then there's no out-of-the-box solution for database as a service for PDBs. We give you different features and functionality of multi-tenant, but we haven't given you a collective package to actually deploy database as a service at the PDB level. And then lifecycle management, again at the PDB level. There's nothing that we provide out of the box that allows you to manage easily the entire lifecycle of the PDB. And then credential management, centralized users, IAM capabilities simply aren't there. You've got to, on-prem, you've got to build this stuff yourself. And then there's no easy interface, particularly a REST interface for those LCM events. And this last bullet point is really critical in that customers are having a difficult time as they are deploying PDBs to maximize the efficiencies of deployment of the PDBs in terms of placement. They don't want to orphan resources. They don't want to necessarily over-provision in certain contexts. And we lack out of the box for on-prem intelligent placement of PDBs for database as a service. So let's just kind of look at the database resource management and lockdown profiles in terms of how we do things in our own cloud. Just a quick recap of terms that we're going to use in this presentation. PDBs, I've already introduced you to that terminology. It is a tenant hosted in a container database. We will refer to different types of container databases. One is just a pod, which is a point of delivery, which is the target pod for a particular provisioning of a PDB for a particular database service. I will later refer to a controller or a central CDB, which is part of our automation framework that basically is the metadata store for deploying and lifecycle management of PDBs. And then lastly, the server, for all intents and purposes, from the way we look at it, is either an engineered system or an OCI compute. Ultimately, in terms of PDB management, and specifically in terms of placement, you really want to understand and control 4 attributes of compute as related to the PDB. CPU, IOPS, memory, and storage. That would be true for any database that you're trying to provision, specifically in the context of consolidation, whether it's non-CDBs or PDBs. Basically, you want to provide a predictable environment, both for the consumer, which basically, when it's bound by these 4 attributes of compute, you know what you're getting when you subscribe to the service. You've asked for a certain number of CPUs, you'll get a certain amount of memory, and you're asking for a certain amount of storage. But you need to bind those attributes so that once provisioned, as a provider, you know that the user is not going to break out and modify the CPU count so that it gets more than it's actually paying for, or more than it's actually asked to be provisioned. So isolating and controlling these 4 attributes to provide a simple, elastic, and predictable environment, both for the consumer, but as well as the provider, allows for a more robust, fast, and frictionless provisioning model where you have bound the attributes of compute, and it becomes a bin packing problem. So this is the first step in solving the efficiencies of placement. Just as a quick refresher, I'm not going to go through this, but in 12.2, we introduced some resource management definitions in the context of the PDB. So specifically, SGA and PGA and CPU count are all configurable in the context of PDB. And we leverage this when defining PDBs for a particular service, for database as a service. It helps you define and scope the shape of the PDB. So the Resource Manager PDB performance profiles were introduced in 12.2. It allows you to define a profile for a class of PDBs. And it's a very simple way of defining a single resource management directive and applying it to a particular class of PDBs. And it's the DBMS Resource Manager package, and it controls the profile name, the shares, which is what we used in 12.1 is basically the definition of caps and shares for resource management of databases. But it also allows you to define the utilization limit and memory limit. So for resource management of the PDB, you're going to define two things. One is these performance profiles to control shares, utilization limit, and memory limit, but also those resource management parameters that are defined here. So let's take a look at that. If we were to define particular class of shapes for PDB as a service or database as a service, most customers are opting for small, medium, and large type t-shirt sizes. So these parameters are now configurable in the context of the PDB. So you'll set a resource management plan, as described earlier, for shares, utilization limit, and memory limit to control things like fair share scheduling for disk and flash, and for example, what's the memory utilization limit, hard limit for disk IOs. But all of these others, you're going to need to find a way to define and control the specific PDB shape for that service. So let's look at an example, a simple example for a small profile for a PDB shape where we define the shares, which is the percentage of resource utilization of the container database that it's hosted in. So this is 2% for a small PDB. And then utilization limit and memory limit, capping flash and disk IO utilization as a percentage of the CPU. But that in and of itself is not enough. And of course, we're going to do that for each of the different shapes. So we've defined a profile directive for each of the PDB shapes for each of the TDB sizes, right? Small, medium, and large. But as I said, that alone will not be enough because we need to control the SGA PGA allocation and the number of sessions and the CPU count. So we implement lockdown profiles, which allows us to define a profile for a particular PDB shape in terms of these four areas: database options, resource management plans, parameter settings, and security, which essentially is broken down into statement execution. So defining the resource management plans and then controlling what is allowable in the context of a PDB to be modified, for example, the parameter settings, and then the database options that can be configured. Essentially, we're defining the stencils associated with a particular PDB shape. So what does that look like specifically before we get into the details? Just a simple example, if you're unfamiliar with the lockdown profiles, it's a declarative way to provide finer granularity in terms of statement execution. So whether it's an alter system, alter session, alter tablespace, alter database, alter pluggable database, you can define at a fine-grained layer what is disabled or enabled in the context of that statement. So as you know, by default, an alter system tends to be binary. You get everything or you get nothing. So a lockdown profile allows you to limit the privileges at a fine-grained layer to only give or enable certain privileges that are specific to the context of PDB execution. So as an example, we'll grant alter statement, disable everything except the things that are relevant in terms of a PDB admin that needs to be more concerned about application code and application execution. So if we were to take a look at our small, medium, and large and extra large shapes, we need to now control the CPU count shares, CPU count sessions, PGA and SGA settings, as well as max auto time and login failures. So what that looks like is basically defining a lockdown profile that allows you to define and protect each one of those, which basically means that at runtime, after the PDB is provisioned and before it's opened, we open for client use, we actually we define and implement each of these different attributes of that profile. So we'll assign a DB performance profile, and this is all executed by PL SQL. So we basically pass in the profile name that the subscriber has asked for. I want a small, so we're going to pass in the DB performance profile associated with that request. And then based on that request, we will apply the lockdown profiles for each of these CPU count sessions, the PG aggregate limit, based on our settings for our service. So we are imposing a specific shape of that PDB, in this case, a small, where we are imposing a CPU count equals 2, the number of sessions that we deem are correct for a CPU count of 2, and then the associated PGA and SGA settings necessary for that service for that PDB shape. And if this is an excerpt from an alert.log in our own execution within the cloud, where you see these actually being set. So at this point, we've created the pluggable database, and now we're imposing a resource management plan and the associated lockdown profiles for each of the different parameters associated with that shape. So at this point, once it's locked down, a user would connect and it will not have the privilege to alter the CPU count or the max servers or SGA or PGA targets or limits, which is a big problem for customers now that are offering on-prem databases as a service private clouds. They provision the database shape, and who's to stop an admin with privilege to go in there and modify a CPU count? Lockdown profiles will provide you that level of isolation. So, oops. We have internally certain scripts that basically issue each of these different statements and create the lockdown profile, passing in the shape of the PDB and the attributes of that shape. And you simply check it by issuing a select on the DBA lockdown profiles to see what's enabled, what's disabled in the context of the statements, in this case, statements that we've locked down. So we've disabled alter table space in this particular service. So a user, in the context of that PDB, cannot alter the table space. So each of these are necessary ingredients to provide a predictable automation framework. So you need to define the various shapes that you want for your particular database as a service, leveraging resource management to restrict the parameters of those shapes, and then define for those other set of parameters like CPU count, SG, and PG, and sessions, which are critical. You're going to define a lockdown profile and apply that lockdown profile. Then you've got a predictable entity that you can manage in terms of life cycles. So in this case, it's a PDB with compute scope to that PDB. So now it becomes a management entity for automation. So this is a slide that was presented at Open World by one of our strategic customers, Swiss Mobiliar. And their use case is basically to migrate from a monolithic app to microservices, and they wanted to implement a CDCI type workflow. And this is an example where they were looking for a back-end database for this workflow, for their application workflow, which was built on Docker. And they evaluated a number of different database solutions, but they wanted, they're an Oracle shop, and they wanted to maintain, the enterprise class database as the back end. Non-CDBs were just too heavyweight, and they tested PDBs, which they determined to be suitable, and I believe they're running on 12.2 now. So this is just an example of how the PDB fits in the workflow. The PDB is not in a Docker image. The PDB is a bare metal install that plugs into the CI workflow, which basically, when a change to the application is detected, TCO basically will call out make a REST call, which invokes a SQL wrapper to create a pluggable database and return the connect string to the flow. They push that connect string into the Docker image through the Docker registry as they build out the application. They've embedded the connect string in that application when they provision the application Docker image. And all of that takes roughly 8 to 10 minutes for the entire stack, which includes a bare metal enterprise edition database on the back end. So looking at our own autonomous database services, basically autonomous is not automation. There's a distinction there. Automation is just one ingredient that enables autonomous. So I'm just going to focus on how we do things internally for our fully managed services. In 12.2, we introduced an 18C, whoops, a typo there, it's management. So for PDB lifecycle management, we introduced what we refer to as fleet management. And there is a central CDB or controller CDB that basically is a metadata backend store that has some intelligence that would allow us to provide metrics to an application that is requesting a provision. So in this case, I want to provision a red PDB, which is basically a database service providing red database provision capabilities. So we basically will do an analysis on utilization patterns in the topology. In this case, there are three target points of delivery, which are container databases for a specific service. And we will invoke a clone operation off of the controller CDB to provision that PDB in the container database, the pod, which best suits the provisioning request made. So in this case, it's a red pod. We keep the metrics in terms of utilization patterns or limits, and we may have multiple red pods. So we provision that red PDB in the red pod that is least used. So if we look at what some customers are doing on-prem for database lifecycle management, this is a simple block diagram of a provisioning service, database as a service, where there might be a self-service portal with some sort of SSO operation, and it hits some kind of control plane. Now, that might be Cloud Foundry, it might be Open Service Broker, it might be just a bunch of scripts that they've written themselves. Well, what we've been working on and what we leverage in our own cloud is this PDB fleet management. And that's this backend metadata store that basically has the topology definitions and utilization metrics associated with a very large deployment model. So a request might come in, and we'd provision it through the central CDB targeting a specific pod in the environment. So at a high level, this is what our own fully managed autonomous services look like. But what we're going to focus on are these three pieces. There's the central CDB, which I've just described. It's a metadata store for the service catalog, pod topology metrics, We've got the RMAN catalog in there. We've got gold image templates for the database services that are actually being invoked through this framework. So that might be general purpose, or LTP, or a warehouse. We've got PDBs in that central CDB that are hosting analytics. And it basically has states and job queues for the provisioning requests that are coming in as arbitrated through some sort of web server. So we deploy a broker, either in WLS or Tomcat, and that's the mechanism to invoke the framework. It's basically highly scalable and stateless. It handles job requests and persistence for retry if a job fails. It will recover and manages the scheduling. So as a job comes in from either the control plane or directly from a service console, the broker will assign a job ID to that particular task, do a lookup in the central CDB, and then communicate with the pod container database for that provisioning request. So if we were to look at an end-to-end operation, we've got a REST request coming into the web service for provisioning. We'll do we basically are pushing JSON docs around, deconstructing those JSON docs and saving them as metadata in the central CDB, reconstructing a JSON doc to push out to the target pod to provision, in this case provision, or execute a particular lifecycle management, where we push that JSON doc via JDBC to the target pod to execute something. In this case, that execution is provisioning. So in a single REST workflow, create a pluggable database, we basically will consume a JSON doc provided to us from the web service that will identify the service that is being requested and the shape of the database requested. We will clone from a template that's stored in the central CDB as a gold image template for that particular service. So we'll clone it. Then we'll apply the resource management and lockdown profiles for that particular service request to satisfy the shape of that PDB. And then automatically, we will rekey the tenant for TD encryption, and then we'll open up the PDB. Part of this entire workflow is because everything is locked down in our own cloud, and we assume that will be the case for on-prem database services, we will implement TDE and SSL, and we'll create the SSH, SSL encryption keys. We will all the credentials necessary to make the connection to that PDB. So the Java key store information, the changes that you need to implement in JDBC driver, and your TNS names aliasing so that you can make a connection into that. We zip it up, and as part of the workflow, pass it back into the requester. So on the back end, as part of the execution in the pod, we've introduced a number of PL SQL packages that handle the back end, handle the REST endpoint, essentially, on the back end database. So everything associated with the lifecycle management of PDB is now executed via this communication flow with a PL SQL package on the back end in the target pod. This is a simple example of what we do in terms of our own curl commands. Basically issuing a REST provisioning request of a database CPU count of 2, max size 25 gig, and the job itself is queued, and we get a job ID on the back end, which is identified here. We can query that job ID to basically get the status, in this case for this PAS of CPU count equals 2, max size successfully provisioned. So, some of these structures in the provision tenant request, where we break down and store the request that is retrieved via JSON doc. So in this PDB cloud service that I'm describing here is that we basically try to encapsulate all the critical pieces of security. We bake that into either the gold image template or in the automation workflow, so that by the time the PDB is opened and available to the client, everything is locked down and protected. So it's all REST enabled. Lots of cool things associated with the PDB lifecycle management automation and end-to-end security. I didn't describe in detail the intelligent deployment and runtime of the PDB placement, but basically the web service will query the central CDB, which is the repository of those metrics, to figure out where's the most logical place to provision the database. And we use a number of different algorithms depending on the service requirement, the database service requirement. Try to keep it simple in terms of the provisioning inputs. If you want small, medium, and large, that's possible, or you can simply define CPU or storage and resize as necessary. There is the concept of pod types, which allows you to pass in a pod type on your provisioning request, which can be used for health checks in terms of logical grouping. So a line of business could be associated with a particular pod type. So you can query that pod type and get stats or health checks for that particular line of business only. We allow for hyperthreading or oversubscription ratios as configured as configurable in the context of the container database. So you can define a pod that allows for oversubscription, or CPU count equals a thread rather than a core. And we handle segregated APIs, so the Service Console UI is different from CloudOps UI. Easy integration with CDCI, so you saw the Swiss Mobile YARM. Currently, they basically are doing very simple operations in terms of provisioning a PDB or destroying a PDB, deleting a PDB, but nothing beyond that. Nothing like flashback a PDB or patch a PDB or relocate a PDB. None of the advanced services are captured in their deployment model. However, it's available with the PDBCS framework. So essentially, the only way you can get to autonomous is if you satisfy the first three requirements, and automation is certainly a large piece of that. You want to provide predictable environment for the end user, and you want to provide produce a predictable environment for provisioning purposes as a producer. And each of these are essential ingredients to autonomous compute.
Yeah, I have a question. It relates more towards management.
Yes.
I noticed on your slide where you targets at E-level.
Okay, you're breaking up. Could you speak closer to the mic, perhaps?
Yeah, I'm talking right into the mic. Is that
okay?
That's better?
Yes.
Okay. So I noticed you have SGA targets set at the PDB level, and I believe I'm not familiar enough with Resource Manager in this context to know how this works. If you set SGA target in the PDB, then that will be the maximum, that will be the SGA allocated to that PDB. It would not go above that. Is that correct?
Correct. Yeah, those would. Yes.
But it would allocate that amount of memory to the PDB.
Yes.
So, I guess one of the concepts of using the CDB, or that I thought was correct, was that the PDBs were able to all share part of the memory that was kind of dynamically that was allocated to the CDB. So if you
that's still the same. They still share the same allocated memory, but now each PDB has a minimum and maximum limits. Basically, they cannot. So if you set, for instance, SGA target, a PDB cannot consume any more than, let's say, 1 gig of the allocated SGA of, let's say, the total of 5 gig. A PDB cannot use more than 1 gig of memory if the SGA target is set to 1 gig.
Right.
Yeah, but there is not a separate memory area allocated for that PDB. So there is a still single allocation, SGA allocation for the CDB, and still all those PDBs utilize that area. But now, basically, to prevent other PDBs from suffering various conditions, such as one PDB taking up all the resources and running away, so we basically introduced these new parameters in 12.2.
Okay.
Yeah. So just quickly to add to what John just said, think of it in terms of mins and maxes and elasticity. So if you set a max limit, or a target or limit for SGA or even PGA, it doesn't mean that the user will necessarily use that max, right? So everything that they're not using remains elastic, and what that means is it can be allocated to somebody else. Mins are basically a partitioning of the memory where you are guaranteeing a minimum amount of memory at startup of that PDB, which is inelastic. So depending on the service and the workload, you'll want to decide, what's the degree of elasticity that I want to enable for this service, and what do I need to preserve or protect in terms of minimums.
Let me ask this in a different way, just to make sure I understand. Say I have a CDB and I have its SGA target set to, let's just say, 10 gig. And I have 5 PDBs inside that CDB. Does the summation of their SGA targets have to be 10 gig or less?
No.
Okay.
If you're setting mins, then yes. But if you're going to oversubscribe memory, which you can do, ultimately what that means is you're going to figure out where do things start to fall apart in terms of performance and availability. So if you oversubscribe, which you would be doing in that case, where you've got the aggregate SGA target limit above what the CDB is configured for, then that's fine. It remains elastic. That means you potentially will get a greater consolidation density where not everybody is using that memory simultaneously. And you do run the risk, as Chan pointed out earlier, is that you may have somebody out there that basically is churning on the memory that may not be your most critical workload.
So at a PDB level, if I set SGA target to say 2 gig in a PDB, it doesn't mean that PDB is actually using 2 gig for its SGA.
Yeah, think of it as an LRU for all of the caches.
Okay, so I can have a 10 gig. I guess when I've looked at it before, I wasn't looking at SGA target in the PDB. I was looking at DB cache and shared pool, and there looked to be some rules around setting those where the summation of those parameters across the PDBs had to be like 50% or less of the SGA of the CDB. But if I'm doing SGA target, that doesn't seem to be the case. I'm setting a parameter that I can grow and shrink in my PDB, and all my PDBs can grow and shrink they can grow to the SGA target, but they're not necessarily allocated that SGA target when they're opened.
Yeah, the way we do that is we set the SGA target and SGA limit to be the same. And that basically tells us that what's the max memory utilization that this PDB can use. And then we start to pack the PDBs in. And then the next is, well, do we want to oversubscribe or not? And then it becomes by what ratio do we want to oversubscribe? So we set the SGA target and limit identical, and we have a CDB setting. And following MAA best practices, we might not want to violate, go above 70 or 80% of available memory. So then it just becomes a bin packing problem, right? So SGA PGA equals 10, and I've got 80 gigs as a percentage, 80% of my available memory. Well, then you get 8 PDBs.
Okay. So is there a need to, and you may have just said this and I missed it, but if I sum up the SGA targets of my PDBs, should they be a certain percentage less than the total SGA target that's allocated to the CD? Say, I don't want to oversubscribe. I just want to have it managed correctly. Does there need to be some percentage of SGA, the SGA target value at the CDB level that is kind of left as, I'll say, CDB only?
Yeah. So again, the best practice, just following the MAA best practices, is to size the container database like a large database. So it's going to, you're going to calculate the SGA settings in function of the available physical memory, and a percentage of that. So that might be, depending on the workloads running in that environment, 70 to 80% of physical memory would be dedicated to the SGA/P settings. And then in the context of the PDBs, if you're not going to oversubscribe, then you're not going to breach that 70/80% of the container database settings. So that's where you would set the SGA target and limit to be the same. And then it's bin packing and looking at the behavior of the applications in the context of those settings. So, start migrating in, keeping a measurement of CDB level performance, and just keep packing them in.
Okay. Thank you.
You're welcome. Are you using multi-tenant today?
We are working on it. We don't have it. We don't have it in any production or really any of our application testing. We're starting to lay it out, and the idea is to definitely go to it. Just trying to figure out how. I think the resource management part is a big deal for us in understanding how to not have a noisy neighbor type situation, and understand how we can allocate memory, not over or under allocated, and just figure out how that works. So that's what I'm trying to figure out at this point.
In many respects, it's analogous to VMs and what you are configuring at the hypervisor level for a particular physical server, and then your allocations for each of the VMs. It's very analogous to that in terms of elasticity of both memory and CPU. And then if you care to, you can hard partition it so that you become inelastic. And all of that is based on what kind of service you want to provide. So low-end environments like test and dev might be totally elastic. You don't need to partition it. You want to just get as much out of those environments as possible. Whereas your production environments, you might just have a single PDB consuming all of the compute resources because it's just the nature of that application.
Okay.
Mr. Huang, I noticed that you've taken yourself off of mute.
Yes, I do have a question. Where can I get more information about this centralized deployment?
Yes, we're targeting that for 18C plus.
Oh, okay.
So it's not available yet.
I see.
But did you find it interesting?
Oh yes, because that's actually we are a SaaS company, so currently everything is using a schema consolidation and causing a whole bunch of problems. So we are looking to convert them to PDBs, And the issue that we're currently facing is we have 150,000 schemas, and obviously one CDB is not going to hold that many PDBs. So the CDB fleet and the combined technology is what I'm actually looking for to see how to actually scale this thing.
How disciplined are you in your SaaS model in terms of interdependencies between the different schemas?
Well, they are all identical. All the schemas are identical.
Okay. So it would be relatively easy to segregate the tenants where you don't have cross-schema dependencies.
Well, they do have cross queries, but that's okay. We can handle those. Yes.
Okay. Can you contact us offline? My email is just john.mchugh@oracle.com, because I don't know if you've had a chance to look at application containers.
Oh, yeah, yes. That's actually, I tried that as well. And I do have some problem about the application sync. Like what happened if I wasn't able to modify the table if there is some idiot run the outer table, disable DDL lock, and I try to add a column to a table, then what's going to happen?
Yeah, so take down my email address. It's firstname.lastname@oracle.com, and reach out to me and let me know what you're doing in terms of your SaaS application and what you want to do, because we've been working internally with NetSuite and Taleo, which are both SaaS applications, in terms of migrating them into multi-tenant. So NetSuite was schema-based. Taleo was SQL Server, and both of them have migrated into multi-tenant. And then obviously the next step for SaaS would be application containers.
Yeah. All right.
Okay. Well, did you guys find this useful?
Yes. Were you indicating that the what you had talked about understanding how to deploy, where to deploy a PDB, et cetera, that would be something that came out later in 18C+?
Yes. Yeah.
In fact, a product, or is that just part of?
Well, it's in production now. We use it internally in various places.
I mean, is it something that would be an additional licensing fee or cost, or is it something that?
Yeah, don't know that yet.
Yeah,
those decisions are made upstream.
Okay, understood. But that is something that sometime later is actually going to be something we could use for an internal cloud.
Well, I guess the point of this is to illustrate how we're doing it internally.
Yeah.
And if this never sees the light of day in terms of general availability, it defines an approach that you might want to take in terms of building your own. I would very much love that you don't build your own and that you just use what we have. And we will probably be running a pilot, which would allow us to explore on-prem deployment of this. Again, it's something that we've been using for a couple of years now, but we see that customers on-prem in their own private database clouds are struggling with database as a service for PDBs, and I think we can help. So, the idea is let's try to get this out GA. If not, at least you understand an approach that you might take.
Okay, thank you.
You're welcome. So, Stephen?
Yes. All done?
I believe so.
Okay, great. I'm glad that worked out.
Gentlemen, thank you very much for your time. And again, Mr. Huang, what is your first name?
It's Pojin.
Oh, Pojin. So if you could just send me an email, again, specifically around the SaaS stuff, we're very interested in pursuing that.
Sure.
Okay. With that, I bid you all a good day.